Rahul Sharma.
And now from Yale Science and Engineering Association, we're awarding MENG 000, a team of 2, Cynthia Gallegos and Annabelle Pena. We have project MTCS 178.
Parth Saxena and Shiladitya Dutta. And Rishik Reddy.
From the Society for In Vitro Biology, we're awarding A.
Yeah, I got $25.
25 bucks?
I check. Deposit this in my
From
account.
NASA,
My
the
account.
Earth Systems Award. All right, high school reaction and solution chemistry honorable mentions. Okay, we actually have 2 second place awards.
And the winners are Austin Liao, Adarsh Sivaraju.
Okay, so my project is how to stop apples from turning brown. So I was inspired to do this project because of my brother. Because in high school, my dad would always cut apples for him, but he would never eat them because at break they would all turn brown. And it got so far that my dad had to actually put an alarm on his phone that said 8 o'clock, take apples out from bag. So this is the solution to those type of problems. So the problem is that apples are one of the most commonly consumed fruits, but when you cut it, then it turns brown or it oxidizes. And what happens is it lowers the nutrition of the apple as well as it makes it more tasteless, mushy, and overall just brown and unappetizing. So which one would you rather have? The left side or the right side?
Left, I guess?
Yeah, pretty sure you want the left side. So my brother always got the right side. That's why he did not want to eat it. So the purpose of this project is to reduce the amount of browning as fast as possible for an extended period of time to make them more fresh. And the solution has to be cheap and easy to use. So now let's see my hypothesis. Soaking the apples in 100-gram citric acid solution will work better to reduce the browning of apples for 3 to 6 hours than 100 milliliter vinegar solution or tap water. So the reason I chose citric acid was for 2 reasons. So as you can see here, this is the main reaction that happens inside the apple that turns it brown. The reduced state, so the main enzyme that causes it is called polyphenol oxidase. And the reduced state is like an apple that's not cut. The oxygen hasn't entered it. But once you cut it, then the oxygen seeps into the inner layers, and then that causes that chemical called polyphenol oxidase to become oxidized. And that starts the whole browning process. So the main goal is to stop this reaction. So citric acid does this in two ways. First, citric acid provides a barrier around this, meaning the oxygen has to react with the citric acid before it can react with this polyphenol oxidase. And the second and the main factor is that the chemical equation, this chemical reaction cannot happen in low pH. Low pH pretty much means high acidity, and the pH of citric acid is 2.2, which means it's very low and it will be very effective. So now let's jump into my experimentation. So I took 4 apples and cut them each into 4 sets of 8 slices. Then I took 3 bowls for the solution. In the first bowl, I added my 100 grams of citric acid. In the second bowl, I added my 100 milliliters of vinegar. And in the third bowl, I added my tap water. Then I took 3 of the 3 sets of apples and put them into their constituent bowls. Now the 4th set of apples, I had to put that into the fridge to stop any premature browning. Because if controlled brown before my experiment begins, then my results will be inaccurate. Next, I laid them all out and took notes at incremental steps in time. At 0 hours, 1 hour, 6 hours, 12 hours, 18 hours, and 24 hours. So now let's see what results I got. So control, or like the regular apples you didn't touch, for 24 hours, they browned 75%, as you would expect a normal apple. But what's great was that citric acid here only browned 25%, meaning it reduced the enzymatic browning by 50%. On the flip side, vinegar browned 80%, which means it increased the process by 5%. And this is because vinegar reacted with the polyphenol oxidase and actually created more oxygen, which in turn sped up the reaction. But tap water did a decent job. It stopped the browning by 15%, meaning that it only browned 60%. So this is my data graphs I found. And what you see here is that citric acid browned at a constant rate of 5% each time, which means that it's more reliable because it's constantly stopping the browning process. And so in conclusion, my hypothesis stated that citric acid would do much better than vinegar and tap water, and that is the case. It was much lower browning. It had much more lower browning. But what happened was citric acid blew away my expectations because I thought it would reduce the browning process by 3 to 6 hours. But instead it did 4 times that, to 18 to 24 hours. And as you can see, that citric acid worked very well. But vinegar increased the browning by 5%, so we do not want to use it. Going to that. And tap water reduced it by 15%. So now let's see how we can save 14.4 billion apples. So, statistics show that today each family wastes 1 apple a week due to browning. Like let's say the father cuts an apple for the son, but he keeps it out for 2 hours and the son throws it away because, hey, this is too brown. So there are 300 million families in the US, and if each of them throws 1 apple per week, then over a span of 1 year, USA as a whole is throwing away 14.4 billion apples just due to common household browning. And apples aren't cheap either, they cost money. So we're actually wasting $1.4 billion. And this can all be averted just by a simple soaking of citric acid solution. But if you don't even have time to soak it in citric acid solution, you can simply fill up the solution in a spray bottle. So once you're done cutting it, you can simply spray it on the apples, and it'll still provide a good barrier to stop the browning. Thank you. So the list of materials we will need for today. First, we are going to need some citric acid. Then we'll need 4 red apples. We'll also need 3 bowls that can fit half an apple. Then we'll also need 4 medium-sized plates. And we'll also need 2 liters of water, tap water. And this container fits 2 liters. And we'll also need 16-ounce vinegar solution, which is just regular vinegar. Hello, we're back and we've cut all the apples into 8 slices each, which gives us 32 slices total. So, now what we'll do is take our vinegar and pour out 100 milliliters of vinegar. So, we need to pour this into the first bowl gently. Now we have to go to the second bowl and we will measure out 8.5 tablespoons of citric acid into the second bowl. Now we have to stir this thoroughly. And our next step, we are going to leave the third bowl as is because this is just plain tap water. Now we're going to place all 8 apples from the vinegar into the solution. Okay, so that was the vinegar solution. And now we'll take the apples from the citric acid. And our next step is to put it. Make sure that all of the apple is inside the water. Now we'll take the apples that are in the tap water plate and put them into the tap water. Once that's done, we'll have to put the control apples into the fridge so they don't spoil. This ensures that we have a proper experiment. So now that all of our apples have soaked and absorbed all their solutions for 30 minutes, we can now begin the experiment. I'll take out the control, which is the one that's in the fridge. So. And now we will place the one that says vinegar into the plate that has the vinegar. Now we will take the apples that said citric acid. Now we will take our apples that were submerged in only tap water. Set our timer to 60 minutes or 1 hour. So this is our timer and we shall start the timer. So it's been 1 hour since we've started our experiment and we can see what has browned. So let's take a look at the control. You can see little patches of brown already forming and that's after 1 hour. Next we have citric acid and this looks almost untouched. It looks very good, almost no browning. And let's take a look at the vinegar. So vinegar has a lot of browning near the top, but is a little less than control. And then let's take a look at tap water. So the tap water seems to have a lot of browning in the top areas. Welcome back. It's been 6 hours and we can see our results. So as you can see, control has browned quite a lot. And then we can take a look at citric acid. Citric acid looks the best, almost no browning. And this is our vinegar. As you can see, vinegar is doing pretty bad too. A lot of browning here. This looks the worst right now. And then tap water is like as brown as control. So it's been 12 hours since we've since we've let our apples to dry out inside in the air, and we can see there's very drastic changes. See this apple right here, it's gone very brown and it's not at all looks appetizing. And this at this stage is when most people throw away their apples and waste their money. But look at the citric acid over here. Almost nothing has changed in 12 hours. You can see there's a slight bit of yellow on the tops, but the rest is there's almost no browning at all. And then now let's look at vinegar. It seems quite brown actually. And now let's look at tap water. Tap water pretty much looks the same as the control. It's been 18 hours since we have started our experiment, and let's take a look at our results. So let's take a look at control. We can see a lot of browning on the sides and on the top, and this doesn't look very appetizing. Now let's take a look at citric acid. Because the apples absorbed citric acid, it wasn't able to brown because of the higher acidity. And look, there's almost no browning at all. And let's take a look at vinegar. Vinegar looks almost exactly like control, but you can see there's a little bit more browning. And tap water looks a little bit better than control because of the moisture that was soaked in, but it's still brown. It still has brown. So it's been 24 hours since we have first started our experiment, and let's look what we have here. As you can see, control has gotten brown. The browning effect has happened. And let's take a look at citric acid. As lived up to our hypothesis, the higher acidity stopped the reactions from taking place, the reaction that caused the apple to become brown. So it looks almost perfect and there's no browning at all. But on the other hand, vinegar seems to have the opposite effect. It seems to have sped up the reaction, and it looks like there's much more browning than the control. So it looks like vinegar was worse. And tap water effects were a little better. As you can see, it's a little whiter than control, meaning there wasn't as much browning. And that's probably because of the moisture blocked out a little bit of the reaction that caused the browning process. But overall, I think citric acid is our main winner, because even after 24 hours, there's little to none of browning.